when we look at this, this is kind of our thought process. What we do first, and we did this one in class together, was we decide what our restricted values in our domain is. That also gives us a hint about the vertical asymptotes. Then how do we find the horizontal asymptotes? Okay, in this particular function, the numerator and denominator have the same degree. And because of that, the shortcut for understanding the horizontal asymptote is to take those coefficients and divide them. 1 divided by 1 is 1. See, we draw in the horizontal and the vertical asymptotes. Then we look at some other things that we know have to be true about the graph. Like this graph has a 0 and 4, 0. How do we find the zeros? You set the numerator equal to 0 and solve. Okay, and then we can find the y-intercept by just plugging in 0 for x. So that gives us some points. Now, this interval work is critical for letting us know what happens at the ends of the graph and what's going on in between and around our asymptotes. So if we look at this, we list on our interval work not only our asymptotes but also our zeros, because that's where the change in signs will occur. So you test the values and get positive, which tells you when you're graphing this and you're approaching this asymptote here at the end, we know it's going to be above that asymptote because the function is positive there. And then as we travel to the right, we're hitting that other asymptote, so it tells me it has to go up. And that's how I know what this looks like without using a graphing calculator. Yes, Ben?
With the y-intercept, if you have like a number on the top that's not 0 and then you have a number on the bottom that is 0, then there's no y-intercept. But if it's flipped, so it's like 0 on top and then like 2 on the bottom, then there's no. If it's 2 on top and 0 on the bottom, there's no y-intercept. But if it's 0 on top and 2 on the bottom, then the y-intercept is 0, 0.
Yeah.
Can you say that
Okay.
again?
So what Ben just said was, if we had 2 divided by 0, that's undefined. Okay, so there's no 0 there. That's because there's a horizontal asymptote on the x-axis. So we have that horizontal asymptote of y equals 0. When does that occur?
There's no actual
When the degree of the numerator is less than the degree of the denominator. Okay? And in that case, we're not going to have those zeros because y equals 0 is a horizontal asymptote. So some things could happen there, and we'll take a look at that. All right.
But if it's 0 over 2, then the 0 is 0, 0.
Yes. So this undefined. This is 0. Did I write the same thing again? I did. This. Ooh, that was some new math, wasn't it? Yeah. First time you write it is this. Second time you write it. All right. So this is undefined.
Well then.
All right. Now, so we were talking about a sign chart here. So in this case, we know it's negative. So up to the 0, it's negative. So we know it's going to ride along here. We know it goes negative here, and it has to ride along that vertical asymptote. And then to the right of this 0, it becomes positive, and we know it's going to ride along the horizontal asymptote. So we can kind of get an idea about the shape of the graph. And the same thing happened with number 2. So we found that excluded value of x equals 3. So our domain was from negative infinity to 3, union with 3 to infinity. That excluded value is my vertical asymptote, x equals 3. So we have this vertical asymptote here. Because the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote of y equals 0. And we do have no zeros here. Okay? Because there's no way to set the numerator equal to 0. Then we do our interval work. We know it's positive on this side of the vertical asymptote, and it's negative on this side of the vertical asymptote. So, how I would start graphing this, because I know it's positive over here, and I know it's approaching 0 at this end. Because that's what it does with those horizontal asymptotes. They become our end behavior, right? So I know it's got to be going this way, so as I go this way, it's going to go up and right along the vertical.
Why do you say that it equals 0 when it's never equal?
It's the limit. It's approaching, yes. the limit of this function is 0. Alright, and the y-intercept actually helped us get this little curve in a better position. Yes, sir?
How do you like start when you're doing like which graph?
Once we have a graph, and right now we're verifying that graph on our calculator, but once we have that graph, we can see the y values for everything except right here at this horizontal asymptote. There's no y value there. So the range for this function is from negative infinity to 0, non-inclusive, union with 0 to infinity. So we do not include.
Is the top one?
And right? Because it goes up forever right here. Yes, sir. Okay. So this is the one I didn't really talk about. So what happens when we factor and we have like factors in our numerator and denominator? Well, we know those will cancel. But what does that do to the graph? So instead of this x equals negative 3 being a vertical asymptote, when it cancels, it becomes a hole in the graph.
What?
Okay? And let's talk about what that means.
Wait,
So instead of there being a vertical asymptote right here, we don't have one. We have just this hole in the graph. Because with our vertical asymptotes, you're going to notice with every vertical asymptote, on one side of the asymptote, our function is approaching positive infinity, and on the other side of the asymptote, the function is approaching negative infinity. That's one way to tell you have a vertical asymptote. If your function's going either direction. Okay? If we look at x equals negative 3, the function's not going different directions on either side. It is not a vertical asymptote. It is a hole. So when we have those factors that cancel, a factor in the numerator that cancels with a factor in the denominator, that is no longer a vertical asymptote, even though it's a factor of the denominator. Because that factor cancels out, instead of a vertical asymptote, it creates a hole in the graph. I want you to take out your calculators and I want you to enter this and let's look. Let's see what happens. You did, and it bothers you.
No, it didn't say anything.
We'll look at the table, and it does say. Speaks loudly.
It will speak loud on the graph.
This one does.
Actions speak louder than words.
You tell me. Oh, is that one?
Yeah, it's 1 to 3, and then this one.
Okay, go ahead and answer, guys. Your eye can't like see.
Error. Graph.
What the? I don't like this.
Okay, so this one we have x squared plus 3x.
How do you?
And then this is divided by x squared plus 5x plus 6. Okay, so we can clearly see that vertical asymptote at x equals negative 2. But we can't clearly see anything where in the function where x equals negative 3. But if we go to the table,
It says error.
why?
Here's a hole.
Because there's a hole. The function has no defined value at negative 2 or negative 3. But negative 2 is a vertical asymptote and negative 3 is not. It is just a hole. And if we look at the graph, we can tell on either side of negative 3 the function is doing the same thing. It's not going in opposite directions. It actually looks continuous.
Yeah.
It's not. Our calculator fakes this out. There is actually a hole in the graph right there. Yes, sir.
You said that the y value of the hole is at 3. How do you find that?
Okay, so what you would do is look at the limit of the function. But what we would do is we would look at the limit of the function as we approach negative 3 from the left and as we approach -3 from the right. Okay? Now, when we have vertical asymptotes, those limits, as we approach them from the left and the right, go positive infinity, negative infinity. They're opposites. But here, as we look at those limits, where would that y value be? That's the way we determine this.
So is it technically estimated? Look at the graph.
Right now it is.
Okay.
So like a doodle.
Yes, sir.
My graph is
This is the real one.
Where did you put any after there?
Yeah.
I said the exact place.
Okay, I'll come look at it in a second. But the app may not know what to do here. Okay. So let's go back to this. Alright, now, what I would do is I would just kind of sketch this in, and where x is -3, we just have an open circle. That's how we show a hole in the graph. It is an open circle. Okay? So, it is continuous everywhere along this path except for right there. There is a hole in the graph right there.
So where do we need to put that?
Okay. Huh?
We need to put that on.
You have to graph the hole, yes. And on tonight's homework, you might have some that have holes. And
Some.
and when I check homework tomorrow, I want to see holes.
So
Yes, sir.
Oh yeah, I'm a burn. This question has to do with number 4. I was looking at it. How come it says the range of just all real numbers? That's a good idea. Shouldn't, like, wouldn't the graph on the bottom left, wouldn't that be negative?
Okay, we'll get there in just a sec. Okay. One more thing that I want to talk to you about. This is division, right?
Yeah. Correct.
Can we write division this way?
No.
Yes, we could.
Oh no.
We can think of this division as long division.
Please don't.
Okay? I would like you to look at this. What is this?
A 1.
1. What was the horizontal asymptote?
1.
1.
Wait a minute, stop.
Okay?
Oh.
So,
Stop.
this kind of tells us where that horizontal asymptote is coming from.
Well, that's just.
So that's just
That's
not
just-
showing the word.
That's
That
just
is,
a wrong way
okay,
of
so
thinking.
Dalton, when we take our shortcut, which I gave you the other day, I gave you the shortcut. You always like to know why. This is the why.
Well, this is just like a longer way of putting reciprocal.
Okay, and what this will lead us to is the other day we said, what happens if the degree of the numerator is greater than the degree of the denominator? And we kind of said, no horizontal asymptote. But some of us saw something was going on with our graph, didn't we? We saw slant asymptotes. And what this leads us into is how to understand those. We're going to add in slant asymptotes as time goes on.
Oh, wow.
Okay?
So diagonal side.
Yeah, so diagonal asymptotes. Yeah.
So they're like, wait a little
So wait,
bit.
can you have like all
Oh, didn't we have this like hyperbolates?
Yes. Yes. Okay. So let's talk about this one. The degree of the numerator is less than the degree of the denominator, so we get that y equals 0. If we did the long division, it would be 0 here, right? Yep. All right, so y equals 0. The restricted values on the domain are your vertical asymptotes because they do not cancel. We do not have holes. Now, how we graphed this one in class on Friday. So we talked about how these signs help us to know where the function is and what it's doing. I did have a question about the range. So, range represents all possible y values for your graph. And because this middle goes forever up and forever down, no y values are excluded. All y values are included in this graph.
You don't have to separate it.
So you do not have to separate it. Because this is continuous. Okay?
Oh, because there's a point in the middle.
Yep. We have that point in the middle.
Ooh. I like the ones that are like 2 rainbows and then a U.
Okay. So,
I'll show you. We have 2 rainbow U's in there. Let's see if we got it.
any questions?
Not yet.
Alright, let's move on then.
Oh, we checked it out.
Okay. This is the one I want to talk through with you guys. So let me erase all this and we're going to work this one together.
Oh, man.
Okay?
Alright.
And
Fair enough.
But why does the range not go away?
There's a little blue arrow.
Don't you need a graph?
That's Twitter talk.
There we go. Alright, so that covers that. I'll miss all of it. Alright, so let's talk through the process. The homework looked good when I went around, so I don't think many of you are just copying my answer key.
No.
Actually, Mr. Campbell's answer key. At this point, just copying the answer key would be
It's your own
detrimental to your next quiz grade. So, what do we do first? We factor. Okay? So we're going to factor x plus 4, x minus 4,
And then X
over x plus 2, and x minus 2. So we have no common factors. No common factors, so will we have holes?
No.
No. Yes, ma'am.
What would happen if you did it faster? If you just left it?
We need to factor in order to find all that important stuff.
Oh, I just.
I mean, if you can look at it and tell what the factors are, that's fine, but in your head, you're factoring. Okay? So, the excluded values for the domain are positive and negative 2. So the domain would go from negative infinity to negative 2, non-inclusive, from negative 2 to 2, non-inclusive, and from 2 to infinity. Okay? So because these values, those restricted values, were not factors of both the numerator and denominator, we have two vertical asymptotes. We have one at x equals negative 2 and another at x equals positive 2. If you wrote plus or minus 2, that's just fine. So now, what we need to do is we need to come over to our graph, and I'm going to sketch a graph real. I'm going to move it over because that's where the writing is. And then we're going to go ahead and put in those vertical asymptotes. And I want to see them on your graph. I don't want to just see them here. I want to see them here. Because if you don't draw them here, your graphs won't look accurate.
Now fix the left one.
It's not gonna let me.
That's alright.
Yeah, just delete it. Sorry. Yeah.
Good enough.
Oh, so
Okay,
close.
and-
That almost ended that.
Alright, so now we're gonna look at the horizontal because my degrees are the same, my shortcut is just to divide those leading coefficients. It comes from that long division there. We would get 1. Alright, so there's my horizontal asymptote. The horizontal, that is at 0. I'll put it at 1 like I just said it was.
Yay.
Alright.
Okay, alright, zeros. Zeros come from setting the numerator equal to 0, so we have zeros at negative 4 and at positive 4. Alright, so we'll come over here, we'll put a 0. We'll come over here, we'll put a 0. Alright, interval work. Let's go do our interval work. Interval work is critical for letting us know where things are on the graph. So what values go on our interval? We've got negative 4, we've got negative 2, we've got positive 2, and we've got positive 4.
Plus minus.
Okay? So when we do this, we get
Positive minus positive.
Once you find the first one, can't you just alternate?
No.
No, John, you can't assume.
You can't.
Can't assume.
Somehow.
we cannot assume because what can happen?
It bounces.
It can do what?
Bounce
Bounce.
back.
Like if it has like a double root, then it'll like. It'll like. It doesn't.
Okay. So this is positive. This is negative. This entire interval is positive, which is kind of interesting because it's going to cross that. This is negative and this is positive. So when we test, we get that. And our y-intercept is negative 16 divided by negative 4, so it is at positive 4. Okay? We're all good. Alright. So, we're going with ends have to be approaching the horizontal asymptote. And this tells me that this end is up here positive, so it's going to be above. and it approaches.
Wait, how do you know that it's below the line?
This is my 0. I know it has to pass through that.
Oh, right, you're right.
And it's approaching here. Okay? Now, I also know that from here to here it's negative, and it's going to follow along the asymptote.
Oh, because it's.
Mm-hmm. Okay. This whole thing is positive, and you would really kind of have to test some values around here to determine that it's going up like this, and it's going up like this. It's obviously going to ride along the asymptotes. Now, look at this. Look at this side of the asymptote going towards negative infinity, this side of the asymptote going towards positive infinity. That's what's going to happen with our vertical asymptotes, right? Okay. All right. Now, over here, it tells me it is negative. So from this point, it's got to go negative and follow along that asymptote. And then here, it's going to go positive, but it follows along this asymptote. And that is how you can graph it without the calculator. Yes, ma'am.
Will the parabola ever pass the asymptotes?
The middle can't. Yes. So that's why I said you would have to test some values, because what's in between vertical asymptotes can cross a horizontal. The ends will not. The middles can.
So I was about to say, eventually it's going to like go up more.
In between two vertical asymptotes, the function can cross a horizontal, just like it did right here. This is a horizontal asymptote, but in between the two verticals, the function crossed a horizontal. It never will at the ends, but it can in the middle. In between verticals.
Can it ever cross vertical asymptotes?
The horizontal asymptote really tells us more about the end behavior of the function, and if you research it, it'll talk about the horizontal asymptotes only in terms of end behavior.
Are we learning
Alright.
a new lesson today?
No.
Thank you.
Alright, I can't make this smaller for some reason.
That's all good, Miss Colby.
There
That's
we
all
go.
good.
Well, it's not all good. She can't make a small one.
Bottom right corner of that.
Did something happen with you?
I really just wanted to shift over. It's okay.
Mouse.
It's okay. Alright, this one's interesting. It had no restriction on the domain. There wasn't one.
Could you get
Because
back to
it's
the bottom?
imaginary, right?
Yeah.
Yeah. So there's no restriction on the domain. Well, if there's no reals here, are there any vertical asymptotes? No. So all we had was a horizontal asymptote, and we had a very interesting looking function.
It's just a bumpy boy.
Yeah. Yeah. It just had this relative min right here. Minimum value. Okay. And take a look at 7 and at 8.
Wow, I actually did surprisingly good on this.
Okay, so over the weekend, I did not ask you to give me these extra characteristics, but I would like you to give them to me on today's practice.
What extra characteristics?
The end behavior as described using limits, where the function is increasing or decreasing. Are there any extrema, max, mins, and what the range is? Okay, so today, on the problems I give you today, I want you to do as much as you can without a calculator. Punch it in the calculator at the end and check it.
I can believe that.
But I think you can do most of it without. And I'm going to stop recording here.